Welcome to remembrance-kjv.com. This is video number 2. In this video, we take a look at an overview on mental arithmetics. There are basically 2 stereotypes about mental arithmetics. By stereotypes, we mean inferences arrived at from limited experience. One of the stereotypes is that mental arithmetics is merely a collection of mathematics tricks. This stereotype tends to imply that mental arithmetics has no provable scientific basis. The other stereotype is that mental arithmetics is rote learning. This second stereotype seems to mention out that there is limited reasoning in the use of mental arithmetics. But given what can be understood from this research, it can be inferred from both stereotypes that mental arithmetics has no basis in the general body of existing mathematical knowledge. But as we shall progress with these video lessons, many will realize that mental arithmetics is prehistoric mathematics of African genesis, and that mathematics tricks are the remains of Africa's mathematical algorithms that have lost their scientific explanation. Whoever has studied mathematics tricks or mental arithmetics in general will come to a conclusion that it is treated best in the 16 sutras of Vedic mathematics. The chief text of Vedic mathematics is the one that is attributed to Jagadaguru Swami Shri Bharati Krishna Tithaj Maharaja. A PDF format of this text is found on the internet, and I have provided a link to the text in the video description. Under the prolegomena, there is this passage. It reads, and I quote, "The Vedic system does not academically countenance or actually follow an automatical or a mechanical rule, even in respect of correct sequence or order to be observed with regard to the various subjects dealt with in various branches of mathematics." End quote. However, in the light of this research, this passage needs to be modified. Vedic mathematics really follow some mechanical rules, but the rules were not or are not known to the authors of Vedic texts. The mechanical rules are found in Africa, while the theory of the rules is claimed to originate from India. I am not quite sure of what to say here. There is a weird tradition among the people of Zimbabwe that India was once part of the Monomotapa Empire. But what I can make from this tradition is that possibly there was a link between India and Africa, and the possibility of this link is to be confirmed further when Vedic mathematics is to be explained under this research within the context of African mathematics. Let us scroll down the pages and take a look at some of the mental arithmetic algorithms in this Vedic text and explain how some of them are used in managing multiplication. Let us try and make the algorithms legible. Let us begin with the first algorithm. The product of the bracket of x minus a multiplied by the bracket of x minus b is equivalent to the product of x multiplied by the bracket of x minus a minus b plus the product of a and b. Let us rearrange the formula to this format and consider x to be any number base. The algorithm, in words, is interpreted as a number which is a less than the base multiplied by a number which is b less than the base gives a result whose base value is equivalent to the base less a less b, and whose unit value is the product of a and b. Since we are all used to the calculations in base 10, we shall start first with an example in base 10. 8 multiplied by 7. 8 is base 10 less 2, and 7 is base 10 less 3. To get the base value or the number of tens in this case, it is base 10 less 2 less 3, which gives 5 tens. As for the number of units, it is 2 times 3, which is 6. The solution of this multiplication of 8 and 7 is therefore 5 tens and 6 units, which is 56. Let us consider the second algorithm that guides on how to manage multiplication. The product of the bracket of x plus a multiplied by the bracket of x plus b is equivalent to the product of x multiplied by the bracket of x plus a plus b plus the product of a and b. Let us rearrange the formula to this form. And again, let us consider x to be any number base. In words, the algorithm is interpreted as a number which is a more than the base multiplied by a number which is b more than the base gives a result whose base value is equivalent to the base plus a plus b and whose unit value is the product of a and b. Since we are all used to calculations in base 10, we shall make use of an example in base 10. 12 multiplied by 14. 12 is base 10 plus 2, and 14 is base 10 plus 4. To get the base value, or the number of tens in this case, it is 10 plus 2 plus 4, which gives us 16. As for the number of units, it is 2 times 4, which is 8. The solution of this multiplication of 12 by 14 is therefore 16 tens and 8 units, which is 168. Let us consider another example involving the second algorithm and carry out multiplication for numbers between 10 and 20. Let us consider 17 multiplied by 16. The base value is 10 plus 7 plus 6, or simply 17 plus 6, which is 23. This is 23 tens, or 230. The unit value is 7 times 6, which is 42. Combining the base value and the unit value, that gives us 272. We have covered 3 examples involving mental arithmetic multiplication as represented by algebraic expressions. Let us take a look at how this kind of multiplication does follow a relatively similar trend to that of addition we covered in video number 1. 23 tens is analogous to 13 of the sum of the thousands column. A transition from higher positional value to a lower positional value is accompanied by placing a zero suffix to the partial solution. 13 becomes 130. The same goes for 23, that becomes 230. The sum of the addition of the second column is added to 130, giving 156. Analogously, the product of the second multiplication is added to 230, giving 272. This trend is noted each time calculations transcend from a higher positional value to a lower positional value. It isn't a trick, but a scientific deduction that arises from the fact that a value to the immediate left is always a base greater in positional value to the one to its immediate right. Let us shift focus and consider how the same mental arithmetic approach can be used with other bases apart from base 10. We shall consider multiplication involving 2 engineering bases, base 8 and base 16. Now consider x to be base 8. This is 8 base 10 or 10 base 8. 6 multiplied by 5. 6 is base 8 less 2 and 5 is base 8 less 3. To get the base value or the number of 8s in this case, it is 8 less 2 less 3. But remember that 8 base 10 is equivalent to 10 base 8. The result is 3 8s. As for the number of units, it is 2 times 3, which is 6. The solution of the multiplication of 6 by 5 is therefore 3 8s and 6 units, which is 3 6 base 8. Now let's consider x to be base 16 or the hexadecimal base. Let us represent base 16 numerals from 10 through 15 by letters of the alphabet A to F. E multiplied by C. E is base 16 less 2 and C is base 16 less 4. To get the base value or the number of 16s in this case, it is 16 less 2 less 4, which gives us 10 or A 16s. As for the number of units, it is 2 times 4, which is 8. The solution of the multiplication of E and C is therefore A 16s and 8 units, which is A8 base 16. Two things can be concluded concerning what we have covered so far in this video. 1. Mental arithmetics is best represented in Vedic mathematics. 2. Algorithms associated with Vedic mathematics or mental arithmetics in general favor base silent arithmetics. They can be used across all number bases without the need of learning the times table of those number bases. Earlier on, we pointed out that mental arithmetics has its mechanical or scientific basis in Africa. The proof is in math games, most of which have their origins in Africa. As shall be seen throughout the research, most games are designed using apparatus of the African Mathematics Laboratory. It is too early for us to cover examples involving this third algorithm, and it is pointless to just apply algorithms without finding out how they originate. We will have to first explain their origins within the African context, and everyone else will apply in his or her desired situation. Let us turn to West Africa. This picture summarizes most of what we are going to cover in this research. It was extracted from the records of Dick Hallebrug of Belgium. The PDF from which the images are got is found on the internet, and it has the title Storytelling in Africa as an Aid for Motivating Art Students for Mathematics. I have also presented a link to the PDF in the video description. The images were first presented in a Belgian show, Africa Plus. It represents African mathematics material and algorithms. Let us identify some of them. This is an algorithm that can be demonstrated using fingers of both hands. Its algebraic equivalent is represented in this format. We shall, in future videos, take a look at the scientific or mechanical methods of deriving the algorithm. Then follow these African number words. It is going to be realized that some African number words were constructed following some simple algorithms that can be used to facilitate mental arithmetic calculations. Next is the abacus. Quite a number of artifacts are to be explained within the context of the African abacus. There is even additional information on how the information of the abacus of Great Zimbabwe managed to reach the Greek world. We also have the musical drums. People should remember that the word number means metered sounds. Mathematics is therefore incomplete in the absence of African music. This is the reason why the intro and the outro of these 3 introductory videos are marked by drum beats. Take effort and subscribe to this channel and be part of the transformation in the way in which mathematics should be taught. Thank you, and meet you in video number 3, where we will continue with part 3 of the introduction.